You are welcome to STEM Cafe, where we make everything science, technology, engineering, and mathematics comprehensive, assimilating, fun, easy, entertaining, interesting. Anything you want to say. We are always excited where we bring our knowledge, where we share knowledge with people in a very easy manner. Please, if you have not subscribed, kindly subscribe, share, make comments, so that as soon as we have any video uploaded, you will be part of the first people to get it. Today we are treating sequence and series. Particularly, we are treating AP and GP, arithmetic progression, geometric progression, and arithmetic series and geometric series. What do we mean by sequence? Let's start. Let's even try to understand what we mean by the word sequence. Sequence is something we have been treating right from the time we were young. Even with series, you will see this quantitative aptitude or quantitative analysis or whatever. They will ask you, if you have a number 2, 5, 8, what will be the next number? And you think, oh, 3, 3, 11, 14. They might give you another one. They might tell you 2, 8, 32. What will be the next number? So what we mean by sequence is the ordered arrangements of numbers under certain rules. That's what we mean. That is, these numbers are arranged and they are being guided by specified rules. That's what we mean by the sequence. Sequence. When we are talking about sequence series, it doesn't end with AP and GP. AP and GP are just the basic forms. That is, arithmetic progression and geometric progression are basic forms. So we will try to see sequence is arrangements of numbers in ordered form under specific rule. That is sequence. Let us now see what we mean by the series. Series is the sum of these ordered numbers. Series is the sum of all these numbers. Like the one I gave as example before. 2, 5, 8. We are not talking. If we now want to talk about the series, we say 2 plus 5 plus 8 plus. Now, why are we studying sequence and series? The first one I explained to you is arithmetic. That is the basic. The arithmetic, that is, they will give you the number to a certain stage, and then they ask you what will be the next one or whatever. Or they might give you the set of numbers, remove some, and tell you the missing numbers, put it there. But in this instance, we are not mathematicians. What do we do? Like if you are given the first number, the second number, and you are asked what will be the 100th number, what will be the 66th number, you should be able to work it out without arranging the numbers one after the other. What mathematicians do is getting the answer within short time. Everybody can get the answer, but as mathematician, we strive to work and get the answer within shortest time. And how do we do that? We bring out formulas and say, wow, this will be the answer. Let's now go to AP, arithmetic progression or sequence. What do you mean by this? This is the one that increases with specified value. With specified value. It increases. Sequence increases with specified value. And when I say increase, that might be too rigid. It can increase, it can decrease. If the value by which it is differing is negative, it will be reducing. So I think it's better to say the sequence increases or reduces with specified value. The first one, most times, those are the very important or key figures in a series. The first term, we refer to it, we use A to represent it most times, but you can use another figure. This increment or reduction or reduction. We use D and we call it difference. So the right order being this sequence differs with specific value. Differs with specific value. Now, let's now bring it to perfect use. Let's bring it out. Let's make it delete. When we have the first term, the next term will increase by D. D can be positive, D can be negative. So we have A. That is first term. This is N1. Or first term. So we can say second term, N2, or second term. Because we say it differs by D, we make that from A plus D. Please remember the first example I gave. 2, 5, 8. You can see it differs by 3. So it's very easy to know. So third term will be equal to A plus D, which is equal to A plus 2D. It's very easy and straightforward. So by the time you get to fourth term, you will see the repetition of how the thing is arranged. You can see that this one will be A plus 2D. It increases by D again. It's A plus 3D. So you see that A is always the same. But this D term is changing. It's changing. And for each term, the number of D is lesser by 1. So nth term will be equal to A plus N minus 1 into D. Straight and direct. Nth term will be equal to A plus N minus 1 brackets into D. So if you are given any term like this, you can use it to say, okay, let's look at this term. A, that is the first term, is equal to 2. D is equal to 5 minus 2, or 8 minus 5, which is equal to 3. Because the increment is the same, is equal to 3. You can also see, that we can use this one to say, okay, what will be the 60th term? Or let's say 61st term. 61st term will be equal to A plus 61 minus 1 into D. And our A is 2. This one is 60 times 3, which is equal to 182. So it makes, you don't need to be saying, okay, number 1, number 2, number 3. That is just what this topic makes us to do. It makes us to get to the answer straight. Now let's look at a situation like this. Now let's quickly do this. This is very simple one. Just to illustrate. We have this. The 30th term of an AP is 96. And the common difference is 3. What is 1 in the first term? 2, 20th term. You can see. So we have a formula. A, first term. D, common difference. And then the formula is nth term is equal to A plus N minus 1 brackets D. Our A, we don't know it. We know our D and we know our N. So N in this instance, when N equals to 30, our term, N term, is equal to 96. D, common difference, is equal to 3. Therefore, 96 is equal to A plus 30 minus 1 into 3. And what does that give us? It makes A 29 times 3. That should be 87. So our A is equal to 96 minus 87, which is equal to 9. We also have to find the n 20th term. So 20th term is equal to 9 plus 20 minus 1 into 3. And that is equal to 9 plus 57. What does that give us? It gives us 66. So you can see how easy it is. Very easy and straightforward. Let's look at another one. So let's see this one quickly. In an AP, the difference between the 8th term and the 4th term is 20. And 8th term is 1.5 times the 4th term. What is the common difference? And 4th term of the sequence. So you can see, all you need to apply is the formula. You know that nth term is equal to A plus n minus 1 into d. Here d is the common difference and a is the first term. So first term d, common difference. Now they have told us that the a term, the difference between the a term and the 28 and the fourth term is 20. So let's see, what is the value of fourth term? You can also say T4 or U4. Sometimes we use this one to represent it. So it's going to be A plus 4 minus 1 D, which is equal to A plus 3D. Eighth term, let's say U8, is equal to A plus 8 minus 1D, which is equal to A plus 7D. You can see, very straightforward. I have been told that the difference between them is 20. Therefore, U8 minus U4 is equal to A plus 7D minus A plus 3D. This is equal to A minus A plus 7D minus 3D. I have been told this one is equal to 20. So D, common difference. D equals to 20 over 4. So the common difference is equal to 5. Now, let's see another relationship. We are told that 8th term is 1.5 times the 4th term. That is, U8 is equal to 1 U4 is equal to 3 over 2 U4. Now, we know that means A plus 7D is equal to 3 over 2 into A plus 3D. And we know the value of D is 5. So we can now say A plus 7 times 5 is equal to 3 over 2 into A plus 3 times D times 5. Let me make it 5. So we can now say that 2A plus 70 is equal to 3A plus 45. Now subtract 2A from here, subtract 45 from here. So you have 70 minus 45 is equal to 3A minus 2A, which is equal to A. So what is 70 minus 45? A is equal to 25. You can see, very easy and straightforward. Just use the formula, you will always get your answers. Now we are told the third term of an AP is 16 and the sixth term is 34. Find the second term. There, you can do this even swiftly, fast. I will tell you after using the formula to get this one. We are told that the third term of an AP is 16, so we know that A plus 2D is equal to 16. I don't want to redefine this term again. And the sixth term is 34. A plus 5D is equal to 34. So with this, you just use the knowledge of simultaneous equation to find D and A. So if we subtract this first one from this second one, we can see that this one is 3D is equal to 18. So D is equal to 6. And we are asked to find the second term. We know that second term, N2 is equal to N3 minus D. So second term is equal to 16 minus 6. D is equal to 10. Very simple and straightforward. If you want to do this, if it's an objective situation, you just think to find D. You just take this one as your A. This is your third term. And you take this one as the fourth term. This will become A. And this one will become your fourth term. That is A plus 3D is equal to 34. And your 3D just be 34 minus 16. What I mean is, if it's an objective situation like what do I call it? Multiple choice question. You just make that A to be 16. And third, fourth, fifth, and sixth. N4 will be equal to 34. So 16 plus 3D will become 34. So D will be equal to 34 minus 16 over 3. So D is equal to 18 over 3. So D is equal to 6. Straight. But if you are, if it's compulsory to show your workings, do it like this. Do it like the first one. I'm just telling you, if you have very limited time, multiple choice question, just go about it in this way. That's all. Since you have found D, just go. The second time will be third term minus D, and you get your 10 straight and direct. So before I proceed, I want to reiterate some points. In arithmetic arithmetic sequence or progression. First term, we call it A, mainly. Common difference, please. Common. We call it common difference because it will be the same all through. We refer to that one as D. And nth term, you can say UN Tn, anything. You can do it in that way. So, and we have this formula that is nth term, let's say Tn, is equal to A plus n minus 1 into D. So it's very key. This is a formula you have to know and store in your memory. So we talk about geometric progression or sequence. Why? In arithmetic progression or sequence, we see that the number increase with common value, that is addition of that common difference. But in geometric progression, the value changes by what we call common ratio. In arithmetic series, it is increasing by addition, but in geometric series, it is increasing by multiplication. So, which means that if you have a sequence like this, 2, 4, 8, 16, etc., the common ratio is T2 over T1 equals to T3 over T2 equals to T4 over T3, and that is R. So, this one is our common ratio. You can see that the formula to get the common ratio is very simple, coming from the understanding of AP. So that is why sometimes they call arithmetic progression linear and geometric progression exponential. They call it exponential. You will see. Now, look at this one. In this situation, A is equal to 2. R is equal to 2. You can see. So, 2. The first one is 2. Look at it. The first one is 2. The second one is 2 times 2. The third one is 2 times 2 times 2. The fourth one will be 2 times 2 times 2 times 2. So, you can see. This is A. This is AR. This is AR squared. This is AR cubed. And if you continue like that, you can see. So that's why we refer to it as exponential. So with this, let us look at another one so that it will be clearer. Let's say we have 2, 6, 12, 36, 108, like that. So with this, you can now say 2 times 3, 2 times, 2, 6. Okay, let's say we have it like this: 2, 6, 18, 54, 162, like that. So our A in this instance, this is our A, 2. AR will be 2 times 3. 2 times 3 times 3, which equals to 2 times 3 squared. And the next one will be 2 times 3 times 3 times 3, which equals to 2 times 3 cubed. And it goes on like that. So the formula for nth term in GP is AR raised to power n. Where A is the AR raised to power n minus 1, sorry. Where A is our first term, R is the common ratio, and n is the term, the number of terms. So that's how we get our value for GP. You don't need to waste time on this. Now, the first and third term of a GP are 5 and 80, respectively. What is the fourth term? For the first question, we know that A equals to 5, C3 is equal to 80, and that is AR squared, which is 5R squared. And we know what R is. R is common ratio. So, therefore, C3 over A, which is 80 over 5 is equal to A R squared over A, and that gives me R squared. So R squared is equal to 16. R equals to root of 16 is equal to 4. So our R in the first question is equal to 4, and we are told to find the fourth term. The fourth term will be equal to T4 will be equal to T3 times R, and that will be 4 times 80, which is 320. I don't need to start finding a again. You get it straight and direct. The second question says, what is the common ratio of the GP? Root 2 minus 1, 3 minus 2 root 2. So, you know that R is equal to T2 over T1, T2 over A. In this instance, our T1 or A is equal to root 2 minus 1. Our T2 is equal to 3 minus 2 root 2. So R that we have to find is equal to 3 minus 2 root 2 over root 2 minus 1. And what do? We multiply, just like we learned in sums. We multiply the numerator and denominator by the conjugate of the denominator. So we have it like 3 minus 2 root 2 into root 2 minus 1 over, root 2 plus 1 over root 2 minus 1 into root 2 plus 1. So, and what will that give us? 3 root 2 plus 3 minus 2 root 2 times root 2, that will be 4. Minus 4, minus 2 root 2 over 1. So if you look at this, 3 root 2 minus 2 root 2, that is root 2. 3 minus 4, that is minus 1. So our answer is root 2 minus 1. So it will be increasing with the value of root 2 minus 1, root 2 minus 1. So now let's talk about arithmetic and geometric mean. What do we mean by this? When we are talking about arithmetic mean, it means that we are trying to insert a number between two numbers that follow each other. Like if we have A, B, these are numbers. They are consecutive numbers in an arithmetic progression. Or we have D, E in geometric mean. They follow each other. How do we now insert a number between them to make sense? How do we insert a number between them to make sense? Let's take that of AP. We have AP like this. A, then we have A plus D. A plus D. I want to insert a number that will make sense between them. So, we are going to have, let's call this one, okay, because this one is equal to B. And B minus A is equal to D. So, in this new arrangement, the common difference will now be different. So, let us insert, let's say G here. So, it's going to be A, G, B. Please follow. It will now be A, G, B. It is now going to be A, G, B. So, what does that mean? This set, we have a different common difference. The common difference for this time will be different. That is, we are going to have, let's call it D1. So, A will still remain A. G, A plus D1. B will be equal to A plus 2D1. I hope you are following. So, what does that mean? It means that our D1 is half of this D. Our D1 is half of this D. So, in essence, what does that mean? B is equal to A plus D. B is equal to A plus 2D1. That's what it means. So our G is equal to A plus D over 2. When you look at this, if we add this one and this one, you will see what it will give us. A plus B will be equal to A plus D, which is equal to A plus 2D1. If you compare with this one, you can have 2A plus D equals to 2A plus 2D1. You can see what G is now. G is now half of the sum of A and B. So the arithmetic mean of the two consecutive numbers, arithmetic mean G will be equal to A plus B over 2. Just like when we have what we have in statistics, when you are talking about mean, is the sum of the two numbers over 2. So this is just to clarify to you that if you are going to insert a number between the two of them, it's going to be half of the sum of the first and the next term. Another thing you can have is you can be asked to insert, to find the geometric mean. And what you mean by that geometric mean is to insert a number between two consecutive numbers in the sequence. Let us say the GP. The first one is D. The next one is E. And we want to insert Y into their midst. So we are going to have D, Y, E. And automatically you know that E is equal to D R. E is equal to D R. So in this new GP, we are going to have E. Let's say the common ratio is R1. E will now be equal to DR1 squared. Please get it. E will now be equal to DR1 squared. Y will be equal to DR1. So we are going to have our sequence like this. DR1 squared. And if you look at it, in the first one, this one is D. In the first one, this one is DR. Are you seeing it now? So if you look at this one, multiplying the first one and the last one, we are going to have D times DR1 squared, which is equal to DR1 all squared. And you can see that is the new term. That is square of the new term we just inserted. So the new term inserted is going to be square root of the first term D times E. You can see. So if you want to insert any new number between two sets, if you have to find the mean, this is how you go about it. The new number in the midst of them will be the square root of the product if it is geometric. If it is arithmetic, it will be half of the sum of the two consecutive numbers. Let's look at another situation where you might be asked to insert 2 or 3 or 4 numbers between two numbers in a sequence. So I've given you a very short way of inserting one mean between two numbers. Now let's look at two numbers again. This one says insert 3 arithmetic means between 8 and 18. What does that mean? It means that 8 and 18, they are in a sequence or progression. Where 8 is the first one. And between 8 and 18, there are 3 other elements. So it's going to be like this. 8, let's insert A, B, C, and 18. So what does that mean? It means that between 8 and 18, there are 3 new elements inserted. So 18 is now the 5th element. Yeah, 8 is the first term. Let's make it like that. 8 is the first term, 18 is the 5th term. Therefore, 18 will be equal to 8 plus 5 minus 1D. So what does that imply? It means that 10 equals to 4D. D equals to 2.5. So A will be equal to 8 plus 2.5. B will be equal to 8 plus 2 times 2.5. And C is equal to 8 plus 3 times 2.5. So what does that give? 8 plus 2.5, that's 10.5. This is 5. This one is 13. And then this one now becomes 15.5. So if you have 2.5, it will give you 18. So you can see how easy and straightforward it is. Let's look at the next one. The next one says insert 5 arithmetic means between 12 and 21.6. So let's look at how that one will be like. It means that between 12 and 21.6 there are 5 terms. That is 12. Let's call it H, I, J, K, L. And then we now have 21.6. So if you look at it, we are going to have 1, 2, 3, 4, 5, 6, 7. So which means that A is equal to 12. T7 is 21.6, which is equal to 12 plus 7 minus 1D, which equals to 12 plus 6D. So please, when you are finding this term, this means either arithmetic or geometric, you find the common difference or common ratio first. That is how it will be very easy and straightforward for you. Find the common difference, unless you have a formula already, which I don't really do for me. But if you can get it straight, get it. But if you first of all get the common difference or common ratio first, it makes your work very easy. Now, I can now say that 21.6 minus 12 is equal to 60. So this one is 9.6. So D is equal to 9.6 over 6, which is 1.6. Therefore, the first time I insert will be H should be equal to 12 plus 1.6, which is 13.6. So I can be adding 1.6 like that. So the next one will be I is equal to 12 plus 2 times 1.6, and that is 3.2. That's 15.2. The next one, J, is equal to 12 plus 3. Yeah. 1.6. That is 4.8. That is 16.8. K is 12 plus 4 times 1.6. That's 6.4. That's 18.4. L is equal to 12 plus 5 times 1.6, which is 12 plus 8. That is 20. So you can see it's very easy and straightforward. Just get your D. Make sure you arrange it first so that you can have pictorial analysis. It will be vivid when you put it like that. Arrange it like this, and then you know how to work it out. The next question says, insert 4 geometric means between 5 and 1215. So what does that mean? It means that. So the next one says, insert 4 geometric means between 5 and 1215. So in essence, it means that we have 5 as the first term. We have something like H, I, J, K, L. Okay, H, I, J, K, and 1215. So in essence, if you look at it, 1, 2, 3, 4, 5, 6. Inserting 4, he says that our first term is 5, and our sixth term is 1215. What is our R? And from there, you can insert all the other terms. Look at it like this. A equals to 5. Sixth term, which is A raised to the power 5, is equal to 1215. Therefore, A r raised to the power 5 over A equals to r raised to the power 5 is equal to 1215 over 5. And that is 243. So r is the fifth root of 243, and that is 3. So now let us insert the 4 terms, or means. The 4 geometric means. It's just like asking, insert 4 terms between them. So H, the first term to be inserted, the first mean to be inserted is 5 times 3, which is 15. J is 5 times 3 squared, which is 5 times 9, and that is 45. K, I is the next one. J is 5 times 3 raised to the power 3, which is 5 times 27, and that is 135. K is 5 times 3 raised to the power 4, and that is 5 times 81. That is 405. That is 405. So those are the 4 terms to be inserted between 5 and 1215. They are the 4 geometric means. The next one says, insert 2 geometric means between 5 and 8.64. So what does that mean? It's like we have 5, A, B, and 8.64. So in essence, it's telling us that 8.64 is the fourth term, and 5 is the first term. So A and B are the ones we are looking for. Therefore, 8.64 is equal to 5 times r into 4 minus 1, which is 5 times r raised to the power 3. So r cubed is equal to 8.64 over 5. So r is equal to cube root of 8.64 over 5. And that is and that is 1.2. 1.2. Therefore, the first term to be inserted will be A, which is 5 times 1.2, which is equal to 6. The second term, B, will be equal to 5 times 1.2 squared, which is 5 times 1.44, equal to 6 times 1.2, which is 7.2. So those are the 2 numbers to be inserted. You can see that this is very easy. This is very easy. It depends on how the questions are worded. Just your understanding will make you flow through easily. Now let's talk about series. Series is about the addition of each element of the progression or sequence. like in AP, we talk about the first term, second term, third term, fourth term to the nth term. So series is about the addition of the first term to the second term, third term, fourth term to the nth term. So here we have, if it's AP now, A plus A2, or let me make it like this: A plus T2 plus T3 plus T4 to Tn. For GB2, I can also say A plus U2 plus U3 plus U4 plus UN. So if we use UN in this instance, not strictly always though, for GP and T for AP. Let's just make it like that. So that is what series is about. Series, so I told you in sequence that in mathematics, we think of how to get our answer quickly. Or like in arithmetic, if I'm going to do it like when we were young, I will say A, I will find T2, I will add it, I will be doing it one after the other. But in mathematics, we look for a formula to get all the whole thing fast. And this has helped us in financial mathematics, like compound interests and so many other mathematics in finances. So understanding of AP and GP is very basic, or prerequisites to learning those topics. Now let's go back to what we are doing. So we know that, let's talk about arithmetic series. We know that our first term is A. Our next term is A plus D. Our next term after this is A plus 2D. So A plus N minus 1D. So the series is going to be A plus D plus A plus 2D plus A plus N minus 1 into D. So you can see, that's how it will continue. So if we depict the series as Sn, that's what we are going to have. So Sn is the sum of all this. How do we get formula for Sn? So that instantly we will be getting our answer without going through the rigor of saying, let me find A, let me find B, add it to it, let me find C, add it to it, till I get to that one. It will take the whole day. What do we do now? Let us rearrange it from the back to the front. Sn is still equal to A plus N minus 1 into D. You can see. So the next one that follows this will be A plus N minus 2 into D. Let me bracket this. The next one will be A plus N minus 3 into D. And continue like that. And the last one will now become A. Please, I hope you understand. I reverse the arrangement from the back forward. So this one now goes like this. Now, let us add this one and this one. Let's see what it will be. 2Sn. If you add this one to this one, it's going to give you 2A plus N minus 1 into D. This next one too, if you add it, A, this one and this one is going to give us 2A plus, this is N minus 2D plus 1. So that is going to give us N minus 1 into D. N minus 1 into D. Again, you can see. The next one again, this one is 2D. Minus 3D plus 2D is going to give us minus D. So we have plus 2A plus N minus 1 into D again. Let us now add this one. Plus 2A plus N minus 1 into D. You can see. That's the trick. If you now add everything, this one and this one is the same throughout. And we have N terms. So which means that everything here is going to be N into 2A plus N minus 1 into D. Can you see? And everything just comes out straight to us. So Sn will be equal to N over 2 into 2A plus N minus 1 into D. Very straightforward. So if you want to add N terms, N number of terms of a sequence of progression, this is the formula you use. We can still bring out another thing. If you look at this, it's equal to N over 2 into A plus N minus 1 into D. if you look at this is nth term. So it's going to be n over 2 into a plus, that is the last term of the sequence in the series, into, let's call this one Tn. Some people might say L, whatever. So this is the last term, Tn. So it's going to be n over 2 into a plus Tn. Very straightforward. That is for AP. There are still some other formulas about the products and so many other things there. Now for geometric series. Geometric series. We know what it will be like. Sn is equal to a plus ar squared plus ar cubed plus ar raised to power n minus 1. You can see. That is what we have. Now, let us now do something. Let's multiply this one by r. And you see what it will show. Rsn is equal to ar plus ar squared plus ar, oh, this one is ar cubed plus ar raised to power 4. You see this one now becomes ar raised to power n. You know before this one you still have ar raised to power n minus 1. Now, if we subtract this one from this one, that is 2 minus n minus 1, you have r Sn minus Sn is going to give us, look at this, this one minus this one will cancel, this one will cancel, this one will cancel, this one will cancel, this one will cancel. So we have only two terms remaining. We have minus a plus ar raised to power n. Those are the only two terms we have remaining. So let's rearrange it. It's going to be ar raised to power n minus a. And you can see the common term here is Sn. So Sn into r minus 1 is equal to ar raised to power n minus a, which is a into r raised to power n minus 1. You can see. So Sn for GP is going to be a into r raised to power n minus 1 over r minus 1. You can see. So that's the formula. If you want to add so many terms, that's what it will give you. And you can manipulate this to work any kind of questions under geometric series. Here, we are talking about sum of geometric terms to infinity. And what do we mean? That is when n is infinity. How can that happen? We might have a situation where the series will go on and on and on and on like that. But we will be able to do that, the sum to infinity, when r is less than 1. And how can that happen? That is, r raised to power infinity will tend to 0. R raised to power infinity will tend to 0. Now, we find from the formula that Sn for GP is equal to a into r raised to power n minus 1 over r minus 1. Now, if in this instance we have seen that this r will tend to infinity, so we are going to have, and r is less than 1 for that to happen. So S infinity will be equal to minus a, because, okay, let me put it like this, a into r raised to power infinity minus 1 over r minus 1. So this will now give a so sum to infinity will now be equal to a into 0 minus 1 over r minus 1. So this will now be equal to minus a over r minus 1. And you know that r is less than 1. So this one will also be negative. So s to infinity. Let's multiply this one by minus 1, this one by minus 1 equals to minus a over r minus 1 times minus 1 over minus 1. And that will be a over 1 minus r. A over 1 minus r. So this is very useful in conversion of recurring decimal to fraction. It's very useful in converting recurring decimal to fraction. Now we have convert 0.3333 to fraction and 0.18181818 like that to fraction. So let's undo the first one. We have 0.3333 It's recurring fraction. So we have it like this, 0.3. So if you look at it, you can now place it like this. 3 over 10. Because this is the first one. The second one is 3 over 100. The next one is 3 over 1000. The next one is 3 over 10,000. So it goes like that. Now, if you look at this, in this instance, r is equal to 3 over 10 divided by 3 over 100 divided by 3 over 10, which is 3 over 100 times 10 over 3. So we have it to be 1 over 10. That is our r. And if you, because you can see this recurring decimal, it's seen as addition of all this to infinity. We can now say our fraction will be sum of this to infinity. What's our first term? A is 3 over 10. R equals to 1 over 10. Therefore, which is the fraction, will be equal to A 3 over 10 over 1 minus 1 over 10. 3 over 10. And if you look at this one is going to be 9 over 10 times 10 over 9. So this is 3. So, which means that when you convert 1 over 3 to decimal, that's what it will give you. Let's look at the next one. We have 0.18, 18, 18, 18, like that. So we can say it is 1, that is recurring. That is 1 over 18, 18 is recurring. So if you want to arrange it as a series, it will be equal to, this one is 18 over 100 plus this next one will be 18 over 10,000. Look at it. This one will be 18 over 10,000. The next one plus like that. So what is our first term? A is 18 over 100. R is equal to 18 over 10,000 divided by 18 over 100, which is 18 over 10,000 times 100 over 18. And what does that give you? Gives this. So our R is 1 over 100. So our fraction can be gotten by the sum, and s to infinity will be equal to A, that is A over 1 minus R, which is 18. Okay, let me put it here. S to infinity will be equal to A over 1 minus R, which is 18 over 100 divided by 1 over 1 minus 1 over 100. And what does that give me? It is 18 over 100 times 100 over 99. So this cancels this. 9 here is 2. 9 here is 11. So my answer is 2 over 11. So the answer is 2 over 11. So when you convert this one to fraction, to decimal, that's what it will give you. So it just needs little thinking to do all these things. Now in closing, let's quickly solve these questions. The 12th term of an AP is 47, and the sum of the first 3 terms is 21. Find A and D. Sum B. Find the sum of the first 15 terms. Now, to solve that one, it says 12th term, which equals to A plus 11D is equal to 47. And the sum of the first 3 terms is 21. That is S3 is 21. And what is the formula for S3? It's 3 over 2 into A plus N into A plus 3 minus 1D. Okay, let's do it like that. And it's going to be 2A, please. 3 over 2 into 2A plus. So I have 3 over 2 into 2A plus 2D equal to 3A plus 3D. So if I work this further, it means that 7 equals to A plus D. Subtracting this from this, it makes you to have 10D is equal to 47 minus 7, which is 40. So D is equal to 40 over 4 is equal to 10. That's the value of D. Now to find the value of A, I can get it from here. So if 7 equals to A plus D, 7 equals to A, D equals to 40 over 10, which is equal to 4. So 7 equals to A plus D. That is 7 equals to A plus 4. A will equal to 7 minus 4, which is equal to 3. So our A is 3, our D is 4. It now says the sum of the first 15 terms. So S15 is equal to 15 over 2 into 2, what is my A? 3, plus 15 minus 1 into 4. And that gives me 15 over 2 into 6 plus 4 times 14. That is 56. And it's 15 over 2 times 62, which is 15 times 31. So 450 plus 15, that's 465. So the sum of the first 15 terms is 465. Now the second one says the first term of a GP is 108 and R, the common ratio, is 3. So we have A unknown, but fourth term, which equals to A R raised to the power 4 minus 1. A into R cube is equal to 108. Fortunately, we have been given R, and R equals to 3. So we can know our A now. Therefore, 108 equals to A times 3 raised to the power 3. Which equals to 27A. So A is equal to 108 over 27. Now let me do something. 3 here is 36, 3 here is 9. So A equals to 4. A equals to 4. We are asked the 8th term. 8th term is equal to A raised to the power n minus 1. A minus 1, let me place it straight. So that will be 4 times 3 raised to the power 7. 4 times 3 raised to the power 7. I use calculator to find that out. I say the sum of the first 5 terms. The sum of the first 5 terms, because it is GP, S5 will be equal to A into R raised to the power 5 minus 1 over R minus 1. What is our A? We know our A to be 4. What is our R? We know our R to be 3. 3 raised to the power 5 minus 1 over 3 minus 1. So this one is 2. So this one is giving me 2, and 3 raised to the power 4 is 81. 3 raised to the power 5 is 243 into 243 minus 1. So this gives me 2 times 2, 42. And that is 484. So the sum of the first 5 terms is 484. For this one, this is just 8, 7, 4, 8. That is the 8th term there. Now the last one. It says the third term of an AP is 20, and sum of the first 10 terms is 275. Find A and D and the 37th term. So let's see how we go about it. The third term, let's say the first term equals A. Third term, let's say the common difference. So third term, T3 will be equal to A plus 3 minus 1D, which will be equal to A plus 2D. A plus 2D. We have T3 now, and it has told us that the third term is equal to 20. So A plus 2D is equal to 20. And it says, and the sum of the first 10 terms is 275. In this place, being an AP, Sn will be equal to n over 2 into 2A plus n minus 1 into D. So for 10, S10, we are going to have 10 over 2 into 2A plus 10 minus 1, 9D. We are told is equal to 275. This one and this one will give us 5. Dividing 2 by 5, we have 2A plus 9D is equal to 55. Is equal to 55. And here also we have, let's multiply this one by 2. We have 2A plus 4D is equal to 40. Let's subtract this one from here. We have 5D is equal to 15. So D is equal to 15 over 5. which is equal to 3. D is equal to 3. Let us now return D to the first one. So A plus 2 into 3 is equal to 20. So A is equal to 20 minus 6, which is 14. So we have gotten A. A is equal to 14. D is equal to 3. We have to find the 37th term. We know that Cn is equal to A plus n minus 1 into D. So 37th term will be equal to, what is our A? 14 plus 37 minus 1 into 3, which is 14 plus 36 times 3. And that is 14. And that is 122. So the 37th term is equal to 122. Thank you very much. We appreciate everything that you have, your patience, and please, if there is any side that you'd like to question about, you can comment, and please let it go viral. Let many people gain from this. Thank you very much, and I appreciate every support given to me. Thank you.